Electronics versus electrical engineering, a cross-comparison of careers, salaries, and outlook. The video Electronics and Electrical Engineering by Engineering Insiders, hosted by Engineer Joe, dives into the often confused fields of electrical and electronics engineering. It seeks to clarify the fundamental differences, career trajectories, and financial prospects of these two dominant pillars of the modern technological world, which underpin a massive $1.5 trillion global market. The host begins by establishing baseline definitions. Electrical engineering is portrayed as a gigantic beast, an overarching discipline dealing with all aspects of electricity, electromagnetism, and electronics. Its scope is vast, ranging from microscopic integrated circuits to nationwide power grids, robotics, and satellite communications. In contrast, electronics engineering is presented as a more focused field, zeroing in on the design and development of the circuit boards and components that form the core of virtually every modern electronic device. Recognizing that these broad definitions still leave room for confusion, the video proposes to find the true distinction by examining the academic journey of an engineering student. Both paths start identically, grounded in the universal fundamentals of advanced mathematics, physics, and programming. Students learn the laws governing the universe like the second law of thermodynamics, humorously applied to a messy bedroom, and the tools to model them. The first major convergence point is in circuit theory. This is the critical foundation for both fields, teaching the techniques to design and analyze the circuits that power everything from smartphones to global data networks. The video uses the example of streaming a YouTube video to illustrate this marvel. A request signal travels. Data is fetched and translated into binary code, ones and zeros, and is then reconstructed by your device into video and audio. This seamless process is a direct application of circuit design principles mastered in these courses. It is after these core courses that the academic paths begin to subtly diverge through specialized concentrations or Here, the video reveals a key insight. The lists of specializations for both degrees look remarkably similar. Both can include embedded systems, microelectronics, telecommunications, signal processing, power systems. This overlap leads to the video's central conclusion. The real difference is not in the fundamental topics studied, but in the scope, scale, and application of that knowledge. Electronics engineers tend to focus on a smaller, though immensely complex, scope, the components and devices themselves. Their expertise lies in selecting individual parts, resistors, capacitors, microchips, drafting schematics, designing printed circuit boards, PCBs, and rigorous testing with lab equipment. They are the architects of the devices. Electrical engineers, while fully capable of performing all the above tasks, also have the training to design and manage the large-scale systems that house or interact with those devices. Using the example of power systems, an electronics engineer might design the precision power supply circuit for a server. An electrical engineer, using the same converter knowledge, could also design the massive infrastructure for a city's power grid, an electric rail network, or the generation system for a wind turbine farm. Therefore, electronics engineering is effectively a vital and massive subset within the broader discipline of electrical engineering. This explains why in the United States, the distinction is often blurred, with most universities offering only a comprehensive electrical engineering degree that allows students to specialize in electronics-focused tracks, career outlook, and salary analysis. Both fields boast strong growth prospects, with nearly 18,000 new jobs projected annually over the next decade, fueled by relentless technological advancement. On salary, the video presents data indicating a slight advantage for electronics engineers. Electronics engineers average base pay of $111,000 per year, with average total compensation including bonuses rising to over $137,000. Electrical engineers average base pay of $98,000 per year, with total compensation averaging up to $120,000. However, Engineer Joe injects crucial professional context from his experience as a practicing electrical engineer. He questions whether this salary gap is as clear-cut in reality, given the significant overlap in job functions. Many professionals with electrical engineer titles routinely perform detailed electronics design work. He suggests that in practice, salaries likely converge much more closely, heavily influenced by the specific industry. For example, semiconductor manufacturing versus utility, power generation, geographic location, and individual specialization rather than the degree title alone. Conclusion and key takeaways. The video successfully demystifies the relationship between the two fields. It argues that the choice is less about picking between two entirely separate professions and more about choosing a point on a spectrum of scale and application within one broad engineering domain. Academic foundation. Identical in core math, science, and circuit theory. Core difference, scope. Electronics engineering is deeply focused on components and circuit design. Electrical engineering encompasses that, but also extends to large-scale electrical systems, power, and electromagnetics. The overlap, immense. Especially in the U.S. job market, where electrical engineer is often an umbrella title. Career outlook, exceptionally strong for both, driven by continuous innovation. Salary, while data may show a premium for electronics roles, real-world compensation is highly dependent on industry, role, and experience, with substantial parity between professionals working on similar technical problems. The final advice is implicit. Prospective students and engineers should focus less on the label and more on the specific technical area. For example, RF design, power, electronics, VLSI, controls that, captivates them, as that specialization will ultimately define their career path and earning potential more than the general degree name. The future for both electrical and electronics professionals remains bright, powered by the current that runs our modern world.